Welcome to the alternating series test. So a quick definition. A series is said to be alternating if the terms of the series alternate sign. So it's typically expressed in one of two forms. So alternating series can be expressed in one of two forms. And those forms are the sum from n equals 1 to infinity of -1 to the n times a sub n, or the sum from n equals 1 to infinity of -1 to the n plus 1 times a sub n. And then this is for a sub n greater than 0. So our a sub n's are positive. An alternating series, essentially either the first option, we would have the odd terms are negative and the even terms are positive. For the second option, the odd terms are positive and the even terms are negative. So these are the two options we have for alternating series. So some basic examples or common examples of alternating series. First up, we have the alternating harmonic series. Which is probably one of the most famous alternating series. This is the series from n equals 1 to infinity of -1 to the n plus 1 times 1 over n. And so this can be expressed as 1, then we would have minus 1/2 plus 1/3 minus 1/4 plus, and then etc. alternating sign. So this is one of your most famous alternating series. Another alternating series we might see, we could see the sum from n equals 0 to infinity of -1 to the n times 1 over n factorial. So for n equals 0, this would be a positive 1. N equals 1, we would have -1. N equals 2, we would be looking at plus 1 over 2 factorial, so plus 1/2. N equals 3, we would be looking at minus 1 over 3 factorial, so minus 1 over 6. Then we would go to plus 1 over 24, then minus, and continue on. So these are a couple alternating series that you might see. That first case, notice that it was the odd n terms that were positive. For the second series, it was the even n terms that were positive. All right, so what is the alternating series test? So the alternating series test says that if a sub n is a positive sequence, which is eventually monotonically decreasing. Technically, the theorem is which is monotonically decreasing. Right. Then, or actually, we'll wait on the then. So if A sub n is a positive sequence, which is monotonically decreasing, and the limit as n goes to infinity of A sub n is equal to 0, then both of the alternating series based off of this sequence converge. So both the sum from n equals 1 to infinity of -1 to the nth times A sub n, and the sum from n equals 1 to infinity of -1 to the n plus 1 times A sub n. Both of those converge. So previously we knew that if the limit was non-zero, right, or sorry, if the limit was greater than 0, then we had the series diverged, right? Now we have if the series is alternating and the limit is 0, limit of the sequence is 0, then the series converges. So in terms of understanding the test, essentially we're adding on an amount and then subtracting off an amount and then adding on, subtracting off. And so we'll, as if the terms are decreasing to 0, then as we add and subtract off, it'll kind of overestimate, underestimate, overestimate, underestimate. So if the terms are going to 0, so first off, if the terms are alternating, right, then we'll add something on, subtract it off. So we add something on, then subtract something off, etc. So you can kind of think of it as here's n equals 1 if n is on the x-axis. Right? Say we start with, and then the value is on the y-axis. So we start with A sub 1 being a positive value. And then if we subtract off A sub 2, right? We subtract off A sub 2 and we land down here. So this will be A sub 1 minus A sub 2. Then we add on A sub 3. So we're going to take that value and go back up. Right? And then we subtract off A sub 4. You can see that the sum, the partial sums are bouncing up and down, right? And that bounce is getting smaller and smaller and smaller, right? So the partial sums sort of bounce up and down. but the bounce is getting smaller and smaller. So until it settles on a value somewhere in the middle, right? So until the sum settles on a value somewhere in the middle. And so the bounce is getting smaller and smaller, going to 0. And so it will settle somewhere. Right? When we just added on, smaller and smaller didn't matter because it has to go to 0 fast enough, right? But when it's going up and down, as long as it's getting smaller and smaller and going to 0, it'll just kind of oscillate up and down, narrowing in on a specific value. Right? Just a comment here. It doesn't really matter if the sequence is monotonically decreasing as long as it is eventually monotonically decreasing. So note. We just need eventually alternating. Eventually positive, or eventually decreasing, right? So we need eventually alternating with the a sub n eventually positive and eventually decreasing. When it comes to series, it doesn't matter what's happening in the first 10 terms, the first 100, the first million. It really just matters what's happening as we go off to infinity. So this, even though the theorem specifies that it should be positive and monotonically decreasing for the a sub n's, technically you don't need that. As long as it's eventually we get this. So that is the alternating series test. In the next video, you'll go ahead and take a look at some alternating series.